All right, we're back. We're on the bottom of page 195, math analysis. We're talking about parametric equations. We just talked about ellipses. Now we have kind of an interesting question that applies to like all sorts of parametrics, not just specifically ellipses, but what do you imagine the resulting curve will look like if you add the coordinates of two parametrically defined functions? So, or parametrically defined curves, I guess it should really be. We're going to say this is 3 plus 2t 4 minus 5t. Like, we recognize this. This is definitely a line with delta y is -5, delta x is 2, so a negative slope. It's like a line with a negative slope. And then this, I think we also recognize this is definitely an ellipse. So you can tell it's not a circle because it's not like 6 and 6 or 4 and 4. Two different numbers, but sine and cosine means it's going to be an ellipse. So like, what do we think is going to happen? Like, one of these looks kind of like this. Kind of, I guess. And then the other one is like 3, I don't know. It's an ellipse that's like bigger this way. So it looks kind of, but it's like, why is it tilted? Do you see how it's tilted? That shouldn't be the case. Can I make it not tilted and still work? No, not really. Well, what if let me try this. I'm just trying things here. I want this to work. No matter what I do, it's like a little off. Weird. All right, anyway. It's an ellipse, so you get that perfect version. Okay, so what's gonna happen? We're gonna have like a point here that's just kind of like moving this way. And then for this one, x starts at a minimum, so it starts over here, and then y increases. So it's gonna go like this, and then get out, and then do this. All right, so what do you think is gonna happen? Like, I don't know how to solicit that from you. So what I'm gonna do is I'm gonna switch over to GeoGebra, see if I can kind of like work out what's gonna happen. I mean, I'm supposed to add them together, right? So what if I just do that? What if I take 3 plus 2t, comma, 4 minus 5t, and then I just add to it 3 minus 4 cosine 2 pi t, comma 5 plus 6 sine 2 pi t. Like, when in doubt, just like follow the directions and see what happens. Let's just treat this like vectors, and we'll just add corresponding components. So I'm going to add this and this. If I do that, that's going to give me 6 plus 2t minus 4 cosine of 2 pi t. And then if I add this and this, so maybe I added this and this to get this. And then I'm going to add this and this to get whatever I get. 9 minus 5t, nope, not comma, plus 6 sine of 2 pi t. Okay, so what could this be? Well, I don't know. I mean, I kind of think I know. What if we look at this as an ellipse, like a kind of ellipse, but not an ellipse that has a fixed center? What if we think of this as an ellipse with a center at 6 plus 2t, comma 9 minus 5t. So the center is going to move. And then the ellipse, you can go 4 in either direction for x, you can go 6 in either direction for y relative to the center, and you're going to start at this left point here and go this way, right? What if we think of it that way? What if? So I think it's an ellipse with that center. Let's go to GeoGebra and see if we can do it. So I'm going to graph maybe a lot of things. I don't really know. I'm going to go to classic. I'm going to wait. And then when it pops up, I'm going to click this button here. Okay. I'm going to leave the labels on, even though I hate that. All right. So first, I'm just going to graph the line that we were given, 3 plus 2t, plus 2t, comma, 4 minus 5t. I'm going to go like 0 to 10. And then zoom way out so that we can actually see what's happening. way out. You know, you can like, if you 2-finger click and zoom, there's like other options, right? Like I can zoom to 50%, which is like farther out, and then move, and then I can do it again, like 25%. There, I'm like seeing everything that I need, but that's too much. But anyway, I just wanted you to know that that was like an option of a thing you can do. Let's plot the other one. Curve 3 minus 4 cosine of 2 pi times, that's not optional, otherwise you're just spelling pit and it doesn't know what to do with it. 5 plus 6 sine of 2 pi times t, comma t. And let's go 0 to 10 again. Okay, so we have an ellipse, which I was expecting, and we have a line, which I was also expecting. So I'm gonna put points on those, a of v, b of v, and let's just go 0 to 10. So 0 to 10. And then, you know, so you can animate it and see what happens. So what I think is gonna happen is we're gonna get some sort of roughly elliptical path, but it's gonna move. So now I'm gonna put in the thing that we think that it is. All right, I'm gonna do that 2 ways. The first way is gonna look weird, and no, you're not gonna like typing this, curve. All right, so I can pull the x coordinate of curve A. So I'm gonna do x of A of t. And then I wanna add x of B of t. So that should be, I'm adding the 2 x coordinates together to see what I get. And then I'm going to add comma y of A of t plus y of B of t. And then t should go from 0 to 10. Look at that. So it's sort of, I think, what I was expecting. So let me put a point on this. So that's c of v. Let's go back. All right, so look at B and C, right? So look at B and C. And you can see, like, if you're just focused on B and C, they're like, it's like spooky action at a distance. Like C and B are always doing exactly the same thing, but C is moving. So C is moving in kind of a weird way. Like that line isn't the center. I'm not even sure really what it is for this particular situation, but I do think that the center was, so this is from the notes that we wrote, 6 plus 2, what? Plus 2t, comma, 9 minus 5t, t, 0 to 10. So I know there's like too much going on. Part of the problem here is that all the labels are showing. Let's hide some labels. Mostly I want to hide the labels on the curves, I think. So don't show a label. Don't show a label. Don't show a label. Fewer labels, the clearer it is. Kind of, I don't know, it's never really very clear in this particular case. Play. Okay, so now let me put a point on curve D. So I'm gonna do D of V. I think that that should be the center. So let's go back and go. Look at that. That's crazy. So now we just have this ellipse. It's like the point C is always on an ellipse. Can I graph that ellipse? I'm not 100% sure, but let's see. I'm gonna make a curve. Okay, so I think that what I'm gonna do is pull x of D plus, I'm just gonna like take, so minus like 4 cosine t. And then y of D, the point D, so that should be the center. And then plus 6 sine of t. I just like want to see the ellipse. I don't really care like how long it takes or whatever, so I'm just gonna go 0 to 2 pi. All right, so is this something, is this intelligible? Should I just change the, all right, let's see. I kind of only want to see like what I need to see. So I'm gonna change the graphics view. I'm gonna like type in what I want. So I'm gonna go from, oh, this never really works. This will work, but watch what I do. and it's like, this is stupidly overly complicated. I'm gonna type x min is like negative equals negative 10. I'm gonna type x max equals like 35. Y min, I'm gonna make negative 50. And Y max, I'm gonna make 20, I guess. Okay, so I did that, and now what I'm gonna do is I'm 2-finger clicking, I'm gonna go to graphics, and up here, I'm just gonna type xmin, and then click. Don't try to tab, it won't work. X max, Y min, not negative Y min, just Y min, and then Y max, and then I'm gonna press enter. And then, so what happens now is when I close this, it'll like actually be what I wanted. So I kind of like lost the joy of the ellipse, but it's kind of working. Oh, and I can't move this at all. That's, I was like struggling to move it. That kind of makes sense because like I shouldn't be able to. All right, play. Okay, so you can see point B's label is so far off. But anyway, you can see point C is always on an ellipse. It's actually just going around an ellipse. Like it doesn't really care that it's also moving through space at the same time. It's just going in an ellipse. It's going in an ellipse with a center at point D. This should kind of like in your mind be like, well, what else can I do? Could you make, instead of point D be a point on a circle, sorry, on a line, could you make it a point on a circle? Could you put a point on another ellipse and have an ellipse going around something that's going in an ellipse, kind of like the universe? Could you make your own solar system at this point? I think you could if you combine all these ideas, but you got to play around with them. So I think for clarity, the best thing to do would be to hide this, and maybe also to hide this, and then potentially to hide a lot of things. I'm going to hide A and B, and then I'll hide the label for D, for curve D. And we get this. I mean, I think that's like pretty clear. That's kind of what I imagine would happen. So another way of imagining what this is, like, imagine someone's standing on a skateboard, and while they're standing on a skateboard, they have like a glow stick, and they're just like whatever, making circles with their glow stick. And at the same time they're making circles with the glow stick, someone is pushing them while they're on the skateboard, right, at a constant rate. And so then you take like one of those long exposures of like a long exposure photograph. I don't know how that's done, but you take the long exposure and you'll be able to see like the path that they traced out. I don't know, maybe if we have some really industrious students, maybe somebody will do that. No one's ever taken me up on that, but I would love to see it. I think that that's basically what this is, and that's kind of what it would look like. So anyway, I'm gonna stop this. This is more like a thought exercise. I think it's a really interesting idea, and I think it opens up so many possibilities of things that you can try to do with parametrics. But so it worked, like our intuition basically works. You do get an object that moves in an ellipse, and it does have a center on this line, or at that specific point. It's on the line, but at like, you know, that point for a specific value of t. Kind of cool. I'm gonna end the video here. I will come back in the next one and we will keep going. So I'll see you there.